Kenneth Chow. This is my quantum gravity video 17. In this video, I'm mainly talking about history. And it's a history of the quantum, the evolution from the quest, the ancient quest for the field of everything, and then which evolved to a quest for a unified field theory, and finally to a quest for a quantum gravity theory. And this is mainly history. So in order, this video is the purpose of this video is to elucidate the relationship between quantum gravity and unified field theory, which you have heard of, and the theory of everything, which is the most the grandeur name of the theory. Ever since the ancient times, the ancient scholars or the natural philosophers have been trying to achieve a theory of everything, which can explain the existence of ourselves and everything around us, and also the rules or the relationship or the laws between these things, if any. Thus, in ancient times and ancient Greece, the scholar Democritus, he proposed that matter in everything was made up of by a large number of different atoms. Other Greek scholars believe that all matters are made up of first four elements: air, fire, water, and earth. This belief, of course, we know is wrong, except the beliefs of the Democritus atoms, which is partly right. In ancient China, Lao Ji, the reputed mentor of Confucius, he proposed this: Tao spawns one, one spawns two, two spawns three, and three spawns everything in the universe. And what's Tao? Lao Ji said, if Tao can be explained, it is not the eternal, the fundamental Tao. In other words, what he meant was that everything in the universe were progressively built up from the eternal and fundamental Tao, which cannot be explained, from the simplest step by step to the complex ones. And I shall later in this video formulate my own interpretation of this, the meaning of this Tao. And you can also refer to my last video. Last video is video 16. There I have implied on the true meaning of Tao. Newton's now the first thing we have to strip from the ancient Chinese and the Greek natural philosophers, right down to Newton. Newton is English physicist. In 1687, Newton published a universal theory of gravitation, and with a gravitation force is equal to Gm divided by r squared. Which is a relation between everything and everything in the universe. Everything and everywhere in the universe. Newton declined to explain the origin of his equation. His equation, that's to say, the gravitational force is equal to Gm over r square. The r is the distance, m is the mass. But in fact, he said something out of his intuition as follows. I have to recite this. We might add something concerning a certain most subtle spirit which pervades and lies hid in all gross bodies, by the force and action of which spirit, the particles of bodies mutually attract one another at near distances and cohere if contiguous, and electric bodies operate to greater distances, as well repelling as attracting. This is important. The neighboring corpuscles, and light is emitted, reflected, inflected, and hit bodies, and all sensations is excited, and the members of animal bodies move at the command of the will. By the vibrations of the spirit, mutually propagated along the solid filaments of the nerves, from the outward organs of sense to the brains, and from the brains into the muscles. That's what he said. Thus, Newton not only related gravity. Here he said something about mutual attraction, that is of gravity, and electromagnetic force. That is what he meant by he said repelling and attracting, both repulsion and attraction, to atoms hidden in all gross bodies. He referred these atoms as particles or corpuscles. But also the force and action of the most subtle spirit hidden in the atoms, to emission of light or geometrical optics. That is what I've just recited. The reflection, and the inflection. These geometrical optics, and his body. What I just recited is heat bodies. Heat bodies is a generation of heat, which is thermodynamics. And it also refer to the interaction between sensory organs. What are sensory organs? There's the ears, the eyes, the nose. These are the mouth, ear, eyes, nose, mouth. And also the senses of the touching senses. For example, the finger touching something. These are sensory organs. Through the nervous system to the brain, and the movement of animal bodies also. But this is very impressive model of a theory of everything. This is what he said in the 1687, what we call the mathematical theory of natural philosophy, a book published by Newton. Next, we'll move to the fields concept. What we mean by field concept? These are actually gradually not introduced by one person, but by a group, a number of scientists. Charles Coulomb, Andrew Marie Ampere, Hans Christian Ørsted, Michael Faraday, and also James Clerk Maxwell from a period from 1760 to 1867, the date of death of the Michael Faraday. This few concept is summed up in Faraday's view. It's like this: that an electric charge sits at the center of a web of electric fields. Whenever two electric charges are moving relative to each other, there's an electromagnetic force emerges between them. You can also find this from my previous video, video 15. This web of electric fields extends spherically in all directions. When in relative motion, one such charge pulls or pushes on another. The other then pushes or pulls on another, and so on and so forth infinitely. And this transmitting an electromagnetic wave. That's what looks like an action at a distance is in fact action by contact, but the contact is by this invisible web of electric fields, electromagnetic fields. And what is the velocity of the transmission by contact? This is the velocity of transmission of this contact is c, the speed of light. It's about 300,000 kilometers per second. As seen from this, the above quote from Isaac Newton, Newton is a very prescient. He knew by his intuition that the light was produced by disturbance of the subtle spirit. That is, in fact, what Michael Faraday called electromagnetic fields, electromagnetic waves. 2 centuries prior, Newton knew this 2 centuries prior to Faraday and Maxwell. Except, of course, he didn't know the details as clearly as Faraday and Maxwell did. Next, we'll move on to the unified field theory. We have so far covered this so-called the theory of everything, the quest for the theory of everything. But now we have moved on to another topic, another name, called the unified field theory. The archaic quest for a theory of everything, for example, by the just quoted the Greek philosopher Democritus and Aristotle, and the Chinese philosopher Lao Tzu, was succeeded by the 17th century English physicist Newton, and by the 18th and 19th century multinational scientists just quoted, there's Charles Coulomb, Andrew Marie Ampere, Hans Christian Ørsted, Michael Faraday, and James Clerk Maxwell. By whom the concept of fields was developed. This is continuing quest for theory of everything finally led to the 20th century quest for unified field theory. They have now developed the theory of the fields, and which will somewhat replace the theory of everything, the formula. Then they have to find a theory of unifying the fields. This evolved into another concept, and in the early 20th century, we will discover more and more elementary particles and more fields and more new theories. For example, Einstein's theory of general relativity in 1915, and Bohr, Heisenberg, Schrödinger, and Paul Dirac's quantum mechanics. The first half of the 20th century was an era of booming scientific discoveries and new theories. This posed a problem. Not only were there now more new elementary particles, but also two theories which, on the face of them, seem to have no relation whatsoever with each other. Just general relativity, on the face of it, seems to have no relation whatsoever with quantum mechanics. Later on, in the 1930s and the 1940s period, there emerged the newly developed nuclear physics and nuclear technologies, as well as the later new electronic physics and the electronics technologies, which ultimately led to such technology, cutting-edge technology as semiconductors, transistors, computers, smartphones, AI, etc. And thus, instead of a seemingly unified physics as it was before the 20th century, for example, in the 19th century, there still seemed to have a very unified physics. Now, it becomes more and more divided. Maybe that's as a subconscious motivations and attempts to unify all the multivarious branches of physics to a unified whole. This attempt, some of which have been verified experimentally, whereas others were not verified. They are summarized as below. We have the first one is Gunnar Nordstrom in 1914. Gunnar Nordstrom in 1914. He sought to unify electromagnetic and electromagnetic fields and gravity based on Maxwell's equations in Minkowskian form, and his own, Nordstrom's own invented scalar theory of gravity in a flat space-time of 5 different axes. What he meant by this is that the 4 dimensions, the familiar 4 dimensions, with only a surface of a 5-dimensional universe. Next, we have in 1918, Hermann Weyl, he sought to unify the gravity and electromagnetism using a modified 4-dimensional space-time geometry. And next, we have 1919, Fyodor Kaluza. He sought to unify the gravity and electromagnetism in 5 dimensions based on general relativity, Einstein's general relativity, because by that time, by 1919, Einstein's already proposed his general theory of relativity. One, two, three. And then in 1923, there's Louis de Broglie. So he sought to unify the old wave theory. The old wave theory has existed ever since about Newton's time to the 19th century. That's from the late 17th century to the 19th century. 17th century, 18th century, 19th century is an old wave theory of light. He tried to unify into a new wave theory of all matters, which include photons, electrons, and protons, which were newly discovered in the early 20th century. And next, you have Oscar Klein, 1924. 1924, Oscar Klein, he sought to unify gravity and electromagnetism in 5 dimensions. And next, we have Yang Chen-Ning, C.N. Yang, and Robert Mills, 1954. They sought to unify the nuclear interactions in a gauge theory of gauge group transformation, SU2 multiplied by U1. And next, we have in the 1960s, we now move on to the 1960s. You have Murray Gell-Mann and Yuval Neumann. Murray Gell-Mann and Yuval Neumann. Yuval Neumann is a Jew. Murray Gell-Mann is American. They sought to unify the newly discovered particles in a SU3 multiplied by SU2 multiplied by U1 gauge theory of quarks and anti-quarks, which were discovered, invented by Murray Gell-Mann. And next, we move on to 1972. We have Stephen Weinberg and Edward Salem and Sheldon Glashow. 1972, they sought to unify under a name of a Grand Unified Theory, GUT. They sought to combine the matter fields of weak interacting particles with the Higgs field, which was proposed by Peter Higgs, a Scottish professor, and they sought to combine the matter fields with the Higgs fields, the photons, and the three new SU2 gauge fields called the W positive, W negative, and EZ neutral to a unified theory of electromagnetic and weak interactions. Weak interaction was discovered somewhat in the part of nuclear physics in the 1930s and 1940s. And next, we'll move on to the early 1970s. You have Yoichiro Nambu and others who proposed a new theory called the hadronic string theory. And next, we have we move on to 1978. They have a trio: Eugene Kremer, Bernard Julia, and Joel Strucker. They propose a new theory called the 11-dimensional supergravity. And next, we move on to 1984. They have John Swartz and Michael Green and Edward Britton, all American physicists. They propose a new theory called superstring theory. These are all the topics. We now come to another topic. It's called the quantization of gravity, or quantum gravity for short. This actually begins. Let's see some part of this. Actually, this began in sometime in about 1949. It continued until 1957. This is the beginning of this quantization of fields, quantization of gravity. This beginning, the person who began this were Rosenfeld, Bergman. Bergman is Einstein's calculator, his assistant, calculating assistant, and Rosenfeld and Dirac is one of the physicists who first formulated quantum mechanics. This period from 1949 to 1957. You have Arnovich, Dessa, and Bisna, which what we call ADM trio. And then you have John Mueller, and Bryce DeWitt. All these persons mentioned are the person who had tried to began this quantization of gravity concept, and then this resulted. What resulted from this concept of quantization is it resulted in a equation called the Euler-DeWitt equation, and also with a concept called the field theory in curved space-time and a spinor formulation. Later, this is followed up by another physicist, a Canadian physicist, Lee Smolin and Carlo Rovelli in 1986, which is called the loop quantum gravity theory. And this also later followed up by Bogomolian, Prasad, Sommerfeld, which are the physics trio are called the BPS by only the acronyms of the name. And the anti-de Sitter space, ADS, BPS, ADS, Blink theory of the icon of this ADS theory is Juan Medicina in 1990. And also there's another new concept by a Paul Weston about 1990, which is called the 5D Space-Time Matter Consortium. There are many others, so numerous I cannot all set out here. I have my deepest apology to those not listed here, but it's still there are too many. Let's see something. Now, after all this, I have introduced the efforts, this endeavors for a quest for the unified field theory, and then a quest for the quantization of gravity or quantum gravity efforts. Now I have to come to the commentary of Stephen Hawking. Stephen Hawking is the most famous icon of the after Newton and Einstein. Stephen Hawking is the first most prominent icon. This I quote from his book, The Brief History of Time. This is a familiar book to many. On page 85, Hawking said, "Our greatest hope for obtaining a complete understanding of the universe from beginning to end arises from combining these two partial theories, The two theories he mainly referred to were general relativity and quantum mechanics into a single quantum theory of gravity. This is what means. He said, in other words, in Hawking's opinion, finally the theory to be which will unify all the different branches, multivarious branches of physics into a theory of everything should be quantum gravity theory. A theory in which the ordinary laws of science hold everywhere. This is important. So what is in the opinion of Hawking should be the properties of a quantum gravity theory which can lead to the theory of everything. A theory in which the ordinary laws of science hold everywhere, including at the beginning of time, without the need for there to be any singularities. What does it mean? It means that actually I can't say what he means, but he means that the equation, the basis of the Big Bang theory, actually. The Big Bang theory was that there was a singularity at the beginning of time, which generates everything, spawns everything in the universe. And what now Hawking saying that there should not be a need for any singularity at the beginning of time. And the ordinary laws of physics, ordinary laws of science hold everywhere and any time, including at the beginning of time. That means it's nothing special. There should not be any special. Time, like the Big Bang, it should not be something like that. That's what actually Hawking means. And then I quote from page 14 to 18 from the same book, Brief History of Time. He says any physical theory is always provisional, of course. No matter how many times the results of experiments agree with some theory, you can never be sure that the next time a result will not contradict the theory. But you can always question the competence of the person who carried out the observation means experiment. In practice, that often happens is that a new theory is devised that is really an extension of the previous theory. The eventual goal of science is to provide a single theory that describes the whole universe. It turns out to be very difficult to devise a theory to describe the universe all in one go. Instead, we break the problem up into bits and invent a number of partial theories. Each of these partial theories describe and predict a certain limited class of observations. That's quoted from the page 14, 15, 16, 17, 18 of the A Brief History of Time. It may be that this approach is completely wrong. If everything in the universe depends on everything else in a fundamental way, it might be impossible to get close to a full solution. By investigating parts of the problem in isolation. Nevertheless, it is certainly the way that we have made progress in the past. That means there's no other way they can do this except to investigate parts of the problem in isolation and then making progress in a way, and finally to trying, attempting to get to the final solution. Today, scientists describe the universe in terms of two basic partial theories: the general theory of relativity and quantum mechanics. They are the Greek intellectual achievements of the first half of the 20th century. Unfortunately, however, these two theories are known to be inconsistent with each other. One of the major endeavors in physics today is the search for a new theory that will incorporate them both. A quantum theory of gravity. That's what this my series from series quantum theory, gravity theory number 1 to now quantum 17, talking about. Hawking said, we do not yet have such a theory. That's what he said in his book, Brief History of Time, 2005. So this must be recognized as such, that this is only in 2005 he said there's no such theory yet. Now, if you believe that the universe is not arbitrary, but is governed by definite laws, you ultimately have to combine the partial theory into a complete unified theory that will describe everything in the universe. The search for the ultimate theory of the universe seems difficult to justify on practical ground. But ever since the dawn of civilization, people have not been content to see events as unconnected and inexplicable. We have craved an understanding of the underlying order in the world. In the world means in the universe. Humanity's deepest desire for knowledge is justification enough for our continuing quest, and our goal is nothing less than a complete description of the universe we live in. That's the quote, end of the quote, from page 14 to 18. This is why it's important, why we have to find to quest for such a quantum gravity theory. And I'll have to mentioned this quote from Hawking, merely to trying to, in relation to my quantum gravity series. I'm not so unselfish as to just to quote another physicist, physicist icon's theory, his view, without any particular purpose. My purpose is just to have quoted in relation to my quantum gravity series. Now first have to say something about the tau of a low G, which I mentioned in the earlier part of this video. We said the tau said, Lao Tzu said, tau spawns 1, 1 spawns 2, 2 spawns 3, and 3 spawns everything in the universe. What is tau? Lao Tzu said it cannot be explained, but I have tried to explain what is tau in my last video, as video 16. That is it is the radiation of energy or mass from the millions of stars in the universe, and from the galaxies. It refer to my last quantum theory, and then with this gravity this radiation of energy then cools down as this expand in the throughout the universe. They will not vanish because there's conservation of the law of conservation of energy and conservation of mass, they cannot vanish. So it's still there. When they cool, as they expand, they cool down. And then as they cool down, they will contract under gravity. This is my understanding of the tau. And then what the in by tau spawns one? Tau spawns element number one, hydrogen. And then what it mean by one spawns two of Lauji's quotation? Means element number one, the hydrogen spawns neutron. One neutron. How to spawn it? As I mentioned in my previous video 3, this in either in a star, in the core of a star, or within the deep confines of a nebula, a hydrogen nebula. You find lots of this nebula, Eagle's Nebula, Fingers Nebula, Pillars of Creation Nebula, and so on and so forth. The Horsehead Nebula is the most famous ones, and these are all tens of thousands of light years in diameter. And then within the cores, they are compressed. Because they are cooled down. This energy has been cooled down, and then they are compressed. Then the compression of a hydrogen will cause its electric fields, exterior electric field, that's what we call the electrons, inside the below the proton surface, and it becomes the neutrons. That's one spawns two. That's what I mean by one spawns two. Element number one, hydrogen, spawns neutron. And then what it mean by two spawns free? Two spawns free means this hydrogen as well as the neutron, they spawn free. That is the helium. Helium is free. Helium, the second element number two, helium. These two spawn free means that the two hydrogen and neutron spawns helium. Helium consists of two hydrogen atoms and two neutrons. Right? So these two hydrogen and neutron spawns the helium. And what is meant by free spawns everything in the universe. And it means the hydrogen and the neutron and the helium atom, they spawns everything in the universe. So thereafter you have lithium, which is 3 hydrogen atoms and 3 neutrons, and then next you have beryllium, 4 hydrogen atoms and 4 neutrons, and then next you have boron, 5 hydrogen atoms and 5 neutrons, and then next you have carbon, 6 hydrogen atoms and 6 neutrons, and nitrogen, 7 hydrogen atoms and 7 neutrons, and oxygen, 8 hydrogen atom, 8 neutrons, and so on and so forth, all the way down up to the uranium, 92 hydrogen atom and 146 neutrons. Okay, these are naturally heavier, naturally found heaviest element is uranium. This is not element number 92. Everything in the universe now, of course, know the heaviest element is 118, element number organism. But all the elements which are after uranium after uranium, they were only produced momentarily in the cyclotron, in the LHC, and so on. So they are not the stable ones which can be found on Earth. That's what our understanding of the tau was tau, and it was tau spawns 1, 1 spawns 2, 2 spawns 3, and 3 spawn everything in the universe. If you refer back to my quantum gravity video 16, then you will find what I mean there. And another thing I want to refer to is that is in Hawking's quote, which I just quoted. It says the mark of a theory of everything is that ordinary laws of science hold everywhere and whensoever. That means to say, if that is that one theory is a correct quantum gravity theory, then it should be applicable to any ordinary laws of science. Already we have in the established in the physics books or physics lectures and so on. You must be applicable to this. If you find a quantum gravity theory, you cannot apply this to the ordinary laws which have already been established, which has withstood the test of time, then they will not be qualified as a quantum gravity theory. And that's why I have tried to apply this my quantum gravity theory in my series video 10, 11, and 12 to the ordinary physics, ordinary laws of physics. And the next benchmark of such a theory, in Hawking's opinion, is that they should be able to combine the two theories, that is to say, general relativity and quantum mechanics into a whole, into one. And if you read my video number 2, number 3, and number 4, then you can see that actually my theory is the Planck black hole theory, and the Planck black hole theory plus the de Broglie matter wave theory, and which is to say the de Broglie matter waves is the result of a Planck black hole. And the Planck black hole, what's the Planck black hole theory? What's the Planck black hole is that according to the Newton formula, Gm divided by c squared, r squared is used to be equal to c squared. That is the mark of a Planck black hole. And this very incidentally, this equation also found in the general relativity, the solution to the Einstein's general relativity equation, field equation, is all Gm divided by r squared to c squared. This also appear in the solution. That actually embodies my Planck-Brown theory embodies is closely related to the Einstein's field equation. And what it also relates to the quantum mechanics. The basic unit of quantum mechanics is the Planck constant, h bar. The constant which as I have demonstrated in my video 2, it is actually equal to a Planck mass times Planck length times c, the speed of light. So this somewhat relates the general relativity to the quantum mechanics. Quantum mechanics basic unit, the spin is h bar, which is Planck mass times Planck length times c, and what's the basic solution? The Schwarzschild solution to the Einstein's equation. It is also equal to Cm divided by R is equal to c squared, and with the m there can be Planck mass, and the R there can be Planck length. It's just perfectly fitting the equation. And then you apply G 6.673 times 10 to the power minus 11 times the Planck mass, the 2.18 times 10, 2.177 times 10 to the power minus 8, divided by the Planck length. Planck length is 1.616 times 10 to the power minus 35 meter. Then it is actually equal to c squared, 9 times 10 to the power 16 meter per second square. So actually the closely related, when you apply both quantum mechanics and the general relativity to the basic quantum units of Planck length, Planck mass, they are the same. They have close relation, very close relation between these two. Yeah, you can have, and in my video 6, I actually point out that both the form of a general relativity equation and the quantum mechanics, the Schrödinger equation, they are wave equations. That's how I relate them to the de Broglie matter wave theory. Actually, in my video 5, you can also see my previous quantum video 5. I actually prove that when both the basic units used are Planck mass, Planck length, that is reduce them to Planck quantum units, then actually there's no difference between the gravitational force and the electromagnetic force. If they look different, it's only because the difference in the distances r in the denominator or in the mass unit in the numerator are different. Usually, I also demonstrate why gravity seems to be only 10 to the power minus 39 to the power minus 39 of the strong nuclear force unit in my, I think it's my video 13. So it's actually I refer this Hawking's comment, that is opinion. What should a quantum gravity theory has? I seem to imagine that my Planck black hole theory plus the de Broglie matter wave theory, which I have collectively called it the new hydrogen atom model. It's fully qualified for this, the fifth Hawking's description of the quantum gravity theory. So I'll stop here because it's running too long, nearly 1 hour.